Good afternoon, distinguished guests, colleagues, and friends. I'm Professor Taryn Barnard. I'm the academic coordinator of the Structured Masters in Engineering Management program in the Faculty of Engineering at Stellenbosch University, which is commonly referred to as the MEM program. It is both an honor and a privilege to welcome you to the inaugural lecture of our Engineering Management Prestige seminar series. It's a faculty-driven initiative that underscores our commitment to fostering innovation and leadership in engineering management. We are particularly grateful to the Faculty of Engineering for sponsoring and initiating this event. It provides us with a platform to engage with thought leaders and share valuable insights that inspire growth and progress in our field. This evening, we are delighted to host Dr. Pieter van Rooyen, who will shortly deliver a thought-provoking address on the topic From Invention to Impact, Building and Scaling Innovation Technologies Across Industries. We are truly grateful for your presence here this afternoon, and it is wonderful to see such a diverse and engaged audience gathered for this special occasion. I would like to acknowledge and extend a special word of welcome to the following guests. Our speaker, Dr. Pieter van Rooyen, and his guest, the Vice-Chancellor of Stellenbosch, Prof. Wim de Villiers, in front, welcome. The Vice-Chancellor Designate and current Deputy Vice-Chancellor of Stellenbosch University, Prof. Diresh Ramjuganath, welcome. Dr. Johan van Zyl, CEO of African Rainbow Capital, and former Vice-Chancellor and Principal of the University of Pretoria. Prof. Kali Pistorius, there at the back, former Vice-Chancellor of the University of Pretoria and the University of Hull in the UK, and also the founding academic coordinator of the MEM program, who I'm so privileged to take this program over from. Prof. Wikus van Niekerk, Dean of the Faculty of Engineering, has also been instrumental in getting this program off its feet. Prof. Pietri Meyer, Acting Dean of the Faculty of Engineering, whilst Prof. van Niekerk was on sabbatical leave. Prof. Corny Skitz is here, Vice Dean of the Faculty of Engineering. Prof. Hubert van Eerden, he's our Chairman of the Department of Industrial Engineering, where the MEM program is currently hosted. Other members of staff, all our students that are also in attendance, and other guests. Finally, and most importantly, I would like to extend a heartfelt welcome to our valued industry partners. The MEM program is deeply rooted in industry relevance, and we place the highest value on your ongoing interest and support of our initiatives. Your engagement is a cornerstone of the program's success and impact. A special note of gratitude goes to Dr. Liesbeth Botha here in front. She's the Chief Technology Officer of Power Optimal, who's with us this evening. Dr. Botha has played a pivotal role in facilitating that Dr. van Rooyen's participation tonight and ensuring the success of tonight's event. We're truly thankful for her invaluable contribution to this event. As you may know, the MEM program is delivered in a hybrid online format. So this allows our students to participate from locations across the globe. And I counted this morning, students from over 20 countries are currently enrolled in this program. For this reason, tonight's lecture will be recorded and made available to our broader student community, many of whom are unable to join us in person. Additionally, we will share the recording with a wider audience interested in the intersection of engineering and management. The Structured Masters program at Stellenbosch University has seen remarkable growth. I worked out that next year we'll be responsible for over 300 students that are set to enroll across the 3 year groups. And this is quite a monumental milestone for us in that we're only in our 3rd year. This expansion includes a significant increase in the number of international students, which we've noticed specifically now in the latest batch of applications. This reflects the program's global appeal and recognition. To enhance the student experience, we have introduced several innovative student-focused initiatives, such as the MEM SharePoint that we developed and launched this year. This platform fosters collaboration and resource sharing. And we're also busy developing a student engagement dashboard that is aimed at identifying and supporting at-risk learners. We actually presented the conceptual paper for this dashboard at the International Conference of Education, Research and Innovation in Seville, Spain last week. So it's been a busy year for us thus far. These advancements are closely aligned with the focus of tonight's lecture by Dr. Pieter van Rooyen, whose career exemplifies the power of innovation in driving impact across industries. Just as Dr. van Rooyen has dedicated his work to bringing novel technologies to market and scaling them across sectors, our MEM program is committed to fostering industry-relevant research and equipping students with the tools to make a tangible impact. The growth of our program, alongside the increasing success of our students' research outputs, underscores the strength of this approach. Notably, half of our students from the most recent and inaugural cohort of graduates graduated with distinction, with many achieving exceptional marks for their innovative, industry-relevant research assignments, which is the equivalent of 4 modules, so 60 credits. This achievement highlights the program's continued focus on developing highly skilled professionals who can address real-world engineering challenges. The expansion of the MEM program, the continued success of our students, and the integration of advanced learning technologies all speak to our mission of preparing the next generation of engineering leaders to excel in dynamic global industries. Following Dr. van Rooyen's lecture, we will invite a brief question and answer session, after which our Dean, Professor Wikus van Niekerk, he will deliver the vote of thanks and provide closing remarks. So it is now my great honor to introduce tonight's distinguished speaker, Dr. Pieter van Rooyen. Just a little bit about him. There's a long list, but I'm just going to share some highlights with you. Dr. Pieter van Rooyen is a distinguished innovator and entrepreneur. He has over 3 decades of experience in inventing, developing, and commercializing groundbreaking technologies across diverse industries, including semiconductors, wireless communication, healthcare, life sciences, image processing, and retail automation. He's a former professor in the Department of Electric and Electronic Engineering at the University of Pretoria. He also holds a PhD in electrical engineering and is the inventor of more than 160 US patents. Driven by a passion for translating innovation into impact, Dr. van Rooyen has been instrumental in founding and securing funding for multiple high-tech startups, generating significant returns for investors and shaping industry landscapes. Notably, he co-founded Genome, which is a pioneering company whose revolutionary Dragon technology dramatically accelerated genomic data analysis. Genome was acquired by Illumina in 2018 for $100 million, and its technology now serves as a cornerstone of Illumina's latest sequencing instruments. Dr. van Rooyen is also the co-founder of Truvian Sciences. It's a company poised to revolutionize point-of-care diagnostics with its near-patient blood testing solutions, soon to be deployed nationwide in retail and workplace clinics. Early in his career, he co-founded Zyre Wireless, which was acquired by Broadcom Corporation for $100 million in 2004, and EcoATM, a leader in automated electronics recycling, which was acquired by Outerwall Inc. for $350 million in 2013. He has also made significant contributions to the emerging field of mobile health, leveraging mobile technologies to deliver innovative healthcare solutions to underserved communities. Dr. van Rooyen's career exemplifies the transformative potential of engineering innovation as he continues to shape the future through technology and entrepreneurship. So please join me in welcoming Dr. van Rooyen to the stage.
Well, thank you very much. And, you know, at the moment I live in San Diego, and they call it the most beautiful city in the US. But now I'm here in Stellenbosch, which is the most beautiful city in the world. So, very great. Great to be here, and, you know, with many familiar faces. And sort of this whole thing came about. You've heard that Lisbeth played a very pivotal role in setting up this whole thing. And she's always asking me, how do you do a startup? And she tells me that I'm mysterious, so tonight I will reveal everything. So this, hopefully you won't be disappointed. But what I would like to do is sort of give you an indication of how each one of these companies came about, and sort of give you anecdotal sort of evidence of how it came about. But so my background is really in electrical engineering, and specifically it's in telecommunications. So the first company, Zyre Wireless, was we did a semiconductor chip, sort of, which is the heart of cell phones. It was a 3G chip way back in the day when 3G was still, you know, something that was really exciting. But the important thing here is the sort of the background and what I did in my studies and how it sort of leads all the way through to genomics. And what's really interesting about that, it's all the detection kind of algorithms that's being applied in mobile phones and telecommunications, and how you do the detection of the bits that you receive, and how the signal processing happens and the statistics that's associated with that. That's actually the fundamental, I would say, technology in everything that I've done so far. You will see, for instance, in Pleno, what we do is we're really implementing something like a telecommunication system in molecular biology to facilitate multiplexing of different targets that you need to detect in a sample. Instead of going through each one of these, I wanted to first give you sort of a general guideline of how I see these things. The important thing, I think, in starting a company and most things in your career is that it's not really, there's not a science to it. It's more like art. So it's very difficult to be not mysterious in telling you exactly what, how things came about. Some of the things that's been important to me, and I know a lot of people here have started their own companies and already has gone through, the whole process. But I just want to give you sort of a general idea of what helped me and what I've seen is important to start a company. And some of these things, as I said, is also very important just in general in careers and if you think of your career and what the next steps are. I think also associated with starting a company is the environment that you're in. It's really important. And again, maybe it's going back to the whole genomics kind of thing because it's nature versus nurture. But there's I think some key genomic sort of DNA kind of things, which are these components in here that gets sort of accentuated if the environment is right. And I think especially for, a facility like this at the University of Stellenbosch, to create an environment where more people can become entrepreneurs, some of these things is also applying to the environment here, of course. So I think the most important thing, as I mentioned, the studies and what you study is really important. In my case, I went all the way through semiconductors to retail automation, where there was a lot of image processing, to genomics, which you would not really necessarily connect to each other. But as I say, fundamentally, there's sort of a general technology sort of that can be applied to many different things. And so you don't, not really when you study, you focused on, or you boxed into one area, but you can really extend that through to many different areas. So one of the other important points is, to start a company is really to really figure out what you're really good at. Instead of focusing on all the things that, you think other people are good at and you would like to do the same kind of thing, I think it's important to figure out what you're good at and, focus on that and try and optimize that. Yeah, and of course, taking risks, a lot of times it's sort of a difficult thing to start a company because you think of all the risks, if the failures are there, what are you going to do? But, and I think the best example there, or equivalent example, is investing in the stock market, for instance. Everybody is always afraid if you put money in the stock market, it's going to go down and you lose all your money. But the thing is, if you don't take the risk and you put your money under a mattress, that money never grows. But if you just stay in there for the long term, there's benefit in taking the risk. But it's the same with, taking risk in your career and doing a startup as well. Strong networks and mentors, of course, that's what a facility like this is really good at. But it's really important to learn from others' mistakes and things that they've done that can be done better and do things in a better way. And then that last point there, a serial entrepreneur, if you're a real sucker for punishment, you continue to do it all the time. But there's always the question of work-life balance, and I have a specific slide on that to explain, how I think of that particular point. So these are sort of some of the foundational things. Then there's the actual company. How do you go about to start an actual company? And I would say, the first thing is to identify a real problem. And quite often, when you define the problem, it's a problem to you, but it's not necessarily a problem for everybody else. So the best way then to figure out if it's really something that's a problem to somebody else is, to talk to, customers, get their feedback, develop a minimum viable product, something that you can show to people. And we've done that basically in all the companies that I've been co-founder of and been involved with. The best way really to do it is to get one of the companies that you would ultimately sell to, a customer, to get them to invest in the company and have some collaboration agreement. That always helps and sort of helps to define the path and to make sure that you stay on the right path. Associated with that is really what kind of company are you busy developing? And that's a really important thing. A lot of times, especially if you're a software engineer, the first thing that you would like to do is just have a service and sort of sell your time, basically, because that's really what it is. The downside of that is that, it's not really a product, so it's not super scalable, because you can only sell your time. Consulting is maybe along the same lines, but it's really important, and none of those are a problem if that's what you want to do, but it's just to really understand exactly what you're doing and what the limitations and the pros and cons of all of this is. If you develop a product, of course, it's more scalable. You can sell something that can be repeated, and for something like that, it's much easier, or maybe even possible, to raise money, because investors would like to invest in something that grows and that has sort of a multiple that's associated with it. The team is extremely important, and that's maybe related to that point of what you're good at. So what I've seen oftentimes with companies and founders, they overlap too much, and so it's very important to stay and define exactly who's doing what, and not to have overlap, because that's where a lot of, and maybe it's true in any relationship, right? So define exactly, what each one will do, and stick to what you're good at, firstly, and secondly, not to overlap too much with the other person, because that's just sort of it's easy to create conflict that way, when we put it that way. The other thing that I found that really works very well as far as a team go is to get groups of people that worked together in the past, because when there are people involved, there's always politics. So if you get people that work together in the past, that all the politics are sort of roughly sorted out and everybody knows where they fit in. So it really helps to sort of streamline the development and to really get the best out of everybody. And then key employees is also another point that sometimes gets overlooked. The founders or even other employees, everybody is not a specialist in what they do. And especially if you do something, what we did at Plino, for instance, or Truvian, it's an instrument that consists of hardware, software, chip design, even consumables, reagents, so it's extremely diverse. So to get key people that can contribute and really lead the teams in these different areas is very important. And also to have the maturity, especially if you're a founder, that you understand that you don't have to know everything, because that's always also can lead to a lot of inefficiencies in the whole system. Yeah, and then of course developing a business model. How do you sell what you're going to develop? be that as a service or a product. But it's important to have a real clear understanding of what the business model is. And that ties very much into the financial planning, which is not the most exciting thing to do, but it's extremely important. Raising money is, always a challenging endeavor. I mean, you basically have to convince people to give you tens of millions of dollars, and they have to trust you and know that you're going to spend that money, not frivolously, but very dedicated and very well. And that's a big responsibility because, especially when the company starts off, you're probably going to raise money from friends and family, so you don't want to create enemies within within your family and your friends. But so raising money is a very important point, and for that you really need to do financial planning and to really understand exactly what the business requires. And then the rest is just hanging in there, focusing, and sticking to what you want to do. And especially if you're a researcher or somebody that's interested in many different things, you tend to think of maybe if we should do this little other thing or that other thing, it's going to be really interesting, and ask the team to quickly do this thing. I learned that very early on. It's a big problem. Everybody, the whole system and the whole organization gets completely thrown off. So it's really important to define exactly what you want to do, stay focused, and really make sure that everybody stays on point with what you're doing. But having said that, and this is a little bit where the art of a startup comes in. So you have to know when to be adaptable, when to change, but also when to stay focused. And that's really a very, very difficult thing to manage and to really get right. And over time, you develop some level of feeling for it, but every time if you do a new project, of course, it's different. So, but that's sort of a key, is when to say no and when to actually change. And as I say, then just hanging in there, lay low, do your thing, and do whatever you need to do to get the product out as cheaply as possible and as fast as possible. So those are the general guidelines. So I'll tell you a little bit about each company, what the challenges were, how we came up with a solution, and some of the small things that really made a difference in each one of these companies that I started. But before we get to that, this is another interesting thing that I've sort of learned, and you can apply innovation in different ways. You can apply it in the technology that you develop, but maybe also in the way that you structure your time. So how it works, at least in the US, you get only 2 weeks of leave per year, and that's not a lot. So this is not really a sine wave. It's more like solid working, and then somewhere in there is a little bit of time off. And this is why you see on social media and everywhere else all these ideas and concepts that people talk about work-life balance. So what I would like to present to you today is a different way of doing it. So if you do a startup, really focus on doing with 200% conviction and time, a 4 or 5 year stretch of doing a company, and then you can take 4 or 5 years off if it worked out. And that's what I've been doing, and it's worked out, I would say quite well, and it was quite rewarding, all the other stuff that I did in addition to starting the companies. So the nicest thing that I've did, I've biked from Cairo to Cape Town, already a long time ago, but it's still a memory that's very strong in my memory and really made a big difference and impact. And travel and do different things, and it actually also gives you the time to think of new things, so that you're not mixing things up. So and this is just my view of things, and of course I'm sure other people will come up with a different way of doing the same kind of thing. So the first company that I started, and this is, I started in 2000. So that was actually when after I left the University of Pretoria, I went to Japan. I did a postdoc earlier in Japan, and my supervisor that I had in Japan, started a new division at Sony in Japan as well. And he invited me to go there, and I went back to Japan, and it was a very interesting time, especially working at Sony. And, as I mentioned, my background, my PhD that I did was in telecommunications, specifically CDMA communications, and what that is, it's each user is assigned a code to do the multiplexing of many different cell phones talking at the same time. And it's based, the standard 3G standard at the time has been based on another standard, probably all familiar with that, called GSM. So if you do anything in 3G, it needs to be backward compatible to GSM. And just to do a GSM chipset is a pretty sizable undertaking. In fact, big companies like Intel spent, I think, billions of dollars to just develop the GSM chipset, and it didn't work out even with that amount of money that they spent. So nevertheless, I was in Japan at the time, and I was hearing about all these startups in Silicon Valley. Everybody's having a great time starting companies, and it gets sold for like billions of dollars. And I thought, well, maybe I should try my hand at this kind of thing as well. So I looked on the web, and those days it was still dial-up connections, but I looked on the web and I saw there was a company doing, a startup as well, doing a 3G, a GSM chipset. So I emailed, and the company's name was Mobilink. So I emailed info@mobilink.com. And I told them, my background is 3G. I would like to start a company if they would be interested in us working together. And unbelievably, 2 weeks later, I got an email back, and the person on the other side was the founder of the company, and he said he was coming to Japan, and he wanted to meet. It was great. We could meet. At the meeting, he asked me, of course, by my background, and I had all my papers journal papers that we've done, and I had 2 books, I think that helped, that I co-authored, and he asked me, what's my business model? I said, wow, business model. I had no idea exactly what a business model was at the time, but luckily there was dial-up internet to look up what it exactly was. But anyway, so I went back to the US to visit them, and they gave me $300,000 to start a company. It was just unbelievable. So we got some people together, some of the old students that I had at the university, and we started working, and then I went back to the US to raise more money, and that was really, really hard. It took almost a year, and I was at the point of giving up, and then I got a call from a VC in San Diego, actually, that they would put in $7.5 million in the company. And it was just like unbelievable. So all those people from South Africa that was here, that was working on the project, went to San Diego, and the good thing there is we were really concerned that we didn't know anything, and we worked very hard and very dedicated, got some other people involved as well, of course. And what we did is we developed this chip that we called spinner chip. But one of the big challenges here was really that, how does this work now? Was that we could obviously not develop a GSM chip, because all the phones that came out, of course, was GSM and wideband CDMA or 3G chipset. So one of the key things then is, how do we develop a product, a chipset that can work and be backward compatible to a GSM chipset? And it's a very simple thing, but this is really the key that made the company successful, and that is we developed this our chip, the wideband CDMA chipset, the 3G chipset, that connected to a GSM chipset via the memory bus, so that all the data that gets received by the 3G chipset can be accessed by the GSM chipset. So that worked out well, but the challenge there was that, of course, as with chips, everything starts to get integrated. And at that time, Wi-Fi was also starting to come out, and there was a big drive to integrate Wi-Fi together with GSM and wideband CDMA as well. So it was very clear that it was a good idea to sell the company or the chip to somebody else, and Broadcom was one of those companies that we worked with, and they acquired the company. But the point here is really that it's very important to, there was clearly a problem at the time, sort of a problem, there wasn't 3D chipsets, but there was also, of course, a big drive by all these other companies to develop 3G chipsets. But to develop at least something that's a product that can be sold, and to have a connection so that it works with existing chipsets and be backward compatible so that this can be integrated into cell phones. So that, I would say, is sort of the key. This is a very simple thing, but it was sort of a key piece of innovation that we did to be able to access the chip via the memory bus. The other key technology that we had, and that was sort of also part of the research that I did at the time, is to have multiple antenna technology that was integrated into the chipset. And if you look at your cell phone today, there's probably, I would say at least 12 antennas in your mobile phone. It's Bluetooth, Wi-Fi, multiple antennas for Wi-Fi. GSM, today we're at 5G. So many, many antennas for all the different standards, and everything needs to be backward compatible to GSM as well. So there's a lot of stuff in there, and it's actually amazing every time you pick up your phone that you can make a phone call. But that was it was a very good learning as a first company, and it was quite a learning experience, to put it very mildly. So we've raised $22 million for that company, which is actually very little for a semiconductor company. I think if you do a semiconductor company nowadays, they're about at 10 nanometers or 5 nanometer technology. It's extremely expensive to be able to do that. So in those days, it was still a little bit more reasonable to be able to do that. Yeah, so I was so excited about, understanding more about starting companies that I immediately thought I wanted to do another one. And so in those days, there was 60 gigahertz was sort of a new technology to do short-range, high-speed communications. And there was another technology called ultra-wideband. And so I think, it was also at the time where it became really expensive to develop chips due to the small, feature set that's required for chipsets. And that one did not go anywhere. And I sort of put this one as a placeholder for all the other ideas that I came up with that didn't go anywhere. So there were many of those in between too. So didn't really raise any money there. That was just my own money that went into that one. And then EcoATM, that was an interesting one. So the first company, we made cell phones, basically with the chips. EcoATM, we thought it was a great idea to destroy all the phones that everybody has in their drawers. Because I think even today, everybody still has like 3 or 4 phones in their drawers, right? And the idea here was to develop a kiosk. And maybe, I'll be quick, I don't know how much time we have, but so the idea for this company came about. A friend of mine and I, we was having coffee there in San Diego, and we were thinking of, something to do. And of course, being with a background of cell phones, it's clear that there's a lot of cell phones in people's drawers. And we're talking about, a way to get the cell phones out of the drawers into our hands. And that evening, I don't know if you can remember on Discovery Channel, I think it was here as well, there was a program called How It's Made. Can you remember that? And what they showed that night when I watched that program was a kiosk of a company called Coinstar. And I'm sure that's not in South Africa, but it's a kiosk where you take all your change, put it in the kiosk, and then it gives you a voucher minus 10% of your money that you just put in to buy things in the store. And then that was sort of where the idea of the kiosk came from, is to have a kiosk in a retail location, and then you put your phone in there. And actually, Coinstar, we contacted them. My friend is very good at convincing people of stuff. He contacted the contacted Coinstar, and they eventually invested in us. They were on the board and ultimately acquired the company as well. So it was actually sort of quite an amazing story as well. But the whole point of this was to get the cell phones out of people's drawers, put it in, every time you go to the supermarket, you see the kiosk, and maybe the third time or fourth time you remember that there's this kiosk that you can put money in, or your phone in, and get money back. So the eco bit is obviously recycling the phones, and the ATM bit is where you get the money. So you put your phone in, you get money back. So it's a different kind of ATM. And actually today, if you go to Walmart, it's one of the biggest retailers in the US, you will see an eco ATM kiosk there in the back. And it always gives me great pleasure. I don't go to a Walmart all that often, but it's great to see it. Yeah, and this company was acquired in 2013 by Outer Wall, which was Coinstar. They sort of changed the name to incorporate all the different kiosks that they have. But the interesting thing about this is, you will see later on Truvian. It's also designed as a healthcare or diagnostic device in retail locations. So it's all the learnings from Eco ATM that sort of help to make the business model viable for Truvian as well. Yeah, so the next company was Edico Genome. So as I mentioned, the first company we created cell phones, the second one we destroyed them, so it was probably time to move on and do something different. So at Edico, we did, so in San Diego, there's a big technology component, like mobile phones and mobile chipsets. Qualcomm is a big company there. And Edico and Illumina is a big sequencing company. So there's a lot of life science companies and technologies that's being developed in San Diego. So I was talking to a friend of mine who was telling me about all these interesting things about genomes, and I think it's interesting to everybody, like DNA, who we are and where it all started and all those kinds of things. So it's very interesting. And he told me that to sequence one person's genome is about generates about 250 gigabytes of data. So it's almost the size of your hard drive of your laptop. That's the size of one person's genome if you digitize it. So it's all the ACGs and Ts. If you put it all in a big file, very big file. And Illumina at that time recommended that you have, I think it was something like 20 servers to analyze the data that comes off the sequencing instrument to do it real time. So that as the data gets generated, that the processing is done roughly at the same time. And again, with semiconductor background, that sounded pretty excessive. And that's sort of how we started looking at what can be done to basically have a chip that goes into a sequencing instrument so that you don't need any servers. And in addition to that, I think this slide is quite interesting. It took just to do the analysis about 30 hours, and on our single chip FPGA solution, it took about 22 minutes, and also in the form factor that you can put into a sequencing instrument. And Illumina just announced, I think maybe a week ago, or maybe a month ago, a new sequencing instrument where this technology is integrated into the sequencing instrument. So it's great. So that worked out well, and they did well to integrate it into the sequencing instrument, and the original vision to have all the analysis on board really worked out. So that was very gratifying for that to happen. And this is just sort of a snapshot picture of all the different components and layers that we developed. So some compression in the chip as well, on all the different components for both germline and somatic variant calling. And we had basically something like an app store. So for different applications, you can develop applications on top of the chip. And yeah, so it's sort of a comprehensive genomic analysis solution. Yeah, and that was about 5 years, and we raised $23 million. Truvian is a project that actually sort of had its origins with Lisbeth at the CSIR. And the idea was there to utilize the sort of cell phone network to deliver diagnostics. And what Truvian does, it does, maybe, I'm sure everybody's heard of Theranos, right? Yeah? So this is Theranos that works. Yeah. So instead of having 1 drop of blood, it takes about 8 drops of blood. So 1 drop is 7 drops too little. But it's basically an instrument that will ultimately go in retail locations. Again, like in the US, it's CVS. They have many clinics. Here, it's like Dischem and a number of other of those pharmacy kind of retail locations. It does the analysis of 34 tests, and these are the tests in about 30 minutes. And you know, this is the original panel that we have at the moment. It's sort of a wellness panel. It does all the clinical chemistry. It's all 3 modalities integrated into one. So it does chemistry, hematology, and immunoassays all in one. And it will have get FDA approval next year, and you know, if things work out, hopefully we'll bring it to South Africa as well. I think it will definitely have an impact here as well. The business model there is to have the instrument, to sell the instrument, or at least to have the instrument available, and then the consumables and the reagents that's associated with it. So every time you do a test, you get these consumables, you put draw the blood, put it in there, and then it does the analysis and send the results, you know, to the patient. So we have raised to date almost $300 million. It's a really big project. It requires FDA approval and what's called CLIA waiver, so that you can run the tests outside of a lab. So it's a really sizable project, and it's still ongoing, but as I say, next year we will have FDA approval for all 34 tests, and it's really the first time that anything like this has gone through the FDA, so it's pretty exciting. The company that I'm busy with now is called Pleno, and what we do here, we've all heard of PCR after COVID, right? So for instance, in a PCR instrument, to look at many different molecular targets, it's pretty limited. You can look at maybe 4 or 5 at a time. And the reason for that is because the way that it's being done is like this. If there's a piece of DNA that you would like to detect, you need to assign the complement of that together with a fluorophore to read out to see if that target is present. And of course, it's almost like a wave division multiplexing system. So because you can only get a limited number of fluorophores in a specific, that do not overlap and have good discrimination. So the challenge is in all the bigger genomic applications, like in oncology, for instance, if you want to do therapy selection, for instance, on specific cancer therapies, what you need is to have a lot bigger number of targets that you can detect, or that you need to detect. And this is sort of the scheme that we've implemented in biochemistry. As I mentioned, it's sort of something along the lines of a telecommunication system with different codes that gets assigned to the different targets. And so what we have is 4 colors, and we basically generate a code word that we associate with a specific biomarker that you're looking for. And we can generate 4 to the 10 different codes, but you don't want to use all of them. You want to have the ones with the best discrimination. And so we can do about 10,000 different targets. And with 10,000 different targets, you can basically look at or develop any of these big, genomic applications. And let me show you a couple of those. some of those applications is infectious diseases, early cancer screening, NIPT, which stands for non-invasive prenatal testing. So if somebody's pregnant, the baby's DNA is actually in the mother's blood. But in a similar way, if you develop cancer, for instance, the tumor DNA, because cancer is really a genetic disease. It's a mutation of the different, it's basically the cells that get mutated. And it has a specific signature for specific types of cancer. And for those kinds of applications, again, the tumor DNA is in your blood. And if you do a blood draw, you can very well and far in advance really see if you're busy developing cancer. So it's sort of a screening test. And if it's positive, then of course, then you go for MRIs or whatever the other diagnostic treatments might be. So these are the kinds of applications which is pretty much covers most of the genomic applications that's currently out there. Can be used in this technology, and the reason why this, apart from the multiplexing capability, why it's really important, is because of the workflow simplicity. Normally they would do these tests using a sequencing instrument. And again, to do sequencing on a sequencing instrument takes maybe, I don't know, days again to do not just the analysis, but also the whole workflow to extract the DNA from the sample, etc. So our technology that we're developing does it a lot faster. Within one shift, you can basically do the detection of all these different biomarkers and do it at a very low cost. So it's sort of like a PCR equivalent of really complicated genomic tests. So, yeah, still going. We raised $50+ million for that company. And then sort of just final thoughts on the mystery of doing startups. I mean, I think the most important thing is, just to do it. Don't think about it too much. If you have an idea, just jump in and do it, right? And the other important thing is, ask. There's always, if you don't ask, they will never get anything answered. So, if the people that's done something that you're interested in, just talk to them and ask them. And what's very important is confidence. If you don't believe in yourself, nobody else will. But above all, be ignorant. Because if you think about it too much, you're probably never going to do it. And don't expect encouragement. In fact, quite the opposite. So always be questioned, and everybody will normally tell you all the things that you're doing wrong, not the things that you're doing right. And then I would say, as you've heard from the first company that I started, Zyro Wireless, is you've got to believe in miracles, right? And miracles don't happen all the time, but they do happen. Not always, but always sometimes. And that's what you have to count on. So that's all for me. Thanks very much for coming out tonight. Really appreciate it. So, any questions? Yes, please.
I'm going to be presumptuous and ask. Yeah, sorry. Two questions, if I may.
Yeah.
So, I'm a gastroenterologist by training, so I'm very much
now I'm in trouble.
into healthcare. So, the two questions. Firstly, you mentioned Theranos. Elizabeth Holmes, who's
Yes.
now in jail.
Mm-hmm.
Theranos did not work because it was a swindle. It was a
Yes.
fraud. In your experience, how did that poison the well for these types of ventures such as Truvian in the United States, especially also given the significant regulatory requirements in terms of Medicare, Medicaid, etc. So that's question number one. And question number two. I mean, this was fantastic. It's really wonderful. But you talked a little bit about nature versus nurture. So were you born an entrepreneur, or did you develop that?
Yeah, well, so let me answer the easy one first, the first one. Yeah, so as far as Truvian goes, yeah, no, of course it was definitely way more challenging to get people to believe it. And that's why you've seen the company is 9 years old. We had to do very extensive clinical trials. We're still busy with clinical trials. We have currently about 50,000 patients that we did clinical trials on. And the FDA, of course, also the requirements, everybody is pretty alert to all the issues that happened there. But yeah, so the only way is basically just to prove that it works. And that's what we've done. But it's been challenging to raise money, especially in the beginning for Truvian. But I do want to point out, the idea started actually in 2010 there with Lisbeth at the CSIR. So it was before Truvian times, or before Theranos times. So, but yeah, it's been a challenge. But that's why you do a startup, is to get to rise to the challenge. So now the second one, I'm not sure. I think if you sort of, maybe it's again what I said earlier. It depends on figuring out what you're good at. I like the adventure of all of this. That's why I'm doing it. Why I like that, I have no idea. But it's compelling. And I think what's really nice about this and what's been rewarding is when it's successful. So for instance, Zaire, the chip was in about 25% of all Samsung phones at some point. Integrated into one chipset. So just having that thought and knowing that it was successful sort of fuels the interest in doing something beyond that. And like Edico, for instance, what's really compelling there is that it's part of sequencing now. So if anybody gets sequenced for oncology or cancer, that's probably going to be done on that system. So it's very rewarding. So I think it sort of builds on top of each other. Any more questions? Easier ones, maybe? Yeah. Yeah.
Now here we are at the university, and how can we create an ecosystem for young students to really continue and follow your road? Because I see that as a challenge. I'm from Germany. I'm here as a guest. And I see the challenge here that industry is not very much engaged here at the university. There's a launch lab and great capabilities, but how can we help the students?
Yeah. So I think, maybe I can start with why it works normally in the US. And I think it's because of the ecosystem. So one of the very important points there is there's capital available. There's a lot of good people available, that has a lot of experience. But I think, you can do high-tech startups like this in the US, just for those reasons. And it's really the expertise is available there as well. What I think maybe is related to one of my earlier points is maybe here applicable as well, and that is to figure out what you can be good at here. And I don't think, it will be difficult to do these kinds of things here because you need a tremendous amount of money and a tremendous amount of expertise. But I think there are other things that can be done here, and to create the environment to support what can be done here. And I think some of the things that can be done here is obviously software development. They've done that very well in India, for instance, as I'm sure you know. And also maybe to get people that's from here to come back and, maybe that's why Lisbeth wanted me to come here, but to, help facilitate an environment like that. So it's basically bring some of the experience that was gathered outside, bring that back, or at least have it available at a regular basis. And to figure out sort of what's the best kinds of projects that work well here. And if it's software, it's software. Maybe it's importing some of the technologies there and deploying it here in a broader way. But I think that's probably the way to think about it, is to figure out what works here and build the ecosystem for that.
And thanks, Peter. Congratulations. It's really impressive. I think one of the tributes you should add there is stamina. Because
But that's where the time off comes in. That
getting
helps.
FDI on any product is, you need a lot of stamina, so congratulations. I think my question is related. If it referred to ingredients of success, capital being one, look at a lot of IP that's locally developed, but one just need fundraise, you need to go to Europe or UK or the States. How can we attract some of the capital to be invested locally? We've got the talent, the capacity to consume goods and services on the continent is massive, if you have a forward-looking view. How can we attract capital to not just South Africa, but the continent for supporting, and I agree with the software point you've made, because that's the only ingredient missing from my point of view, and important ingredient to get access to. The alternative is diluting IP, diluting human capital to other markets.
Yeah, so I would definitely say there's a lot of the people here. There's a lot of people from here that went to the US and that's been successful. So there's clearly the educational system here is very, very good and well suited for basically anything. So the human capital is certainly here. And I think success breeds success, right? So it would be good to have one success here, and there's actually been many successes here already, but maybe to do a little bit better PR about the successes. And, I think really success attracts success. So, if a company is successful, to really make it very visible, and then there will be follow-on success and capital that comes from that as well. Yes? Yep. Yeah, please. Yeah. Oh, I see. Yeah. Yeah.
Hi, yes. Very impressive what you've achieved, specifically the frequency. I've been also in business, but with a much longer frequency in terms of, number of successes there. But what I would like to know is how important is the exit, for two reasons. One is, if you didn't achieve the first exit, would you have had the confidence that I can build up a business, make money out of it? And then secondly, and that relates a little bit to the questions that were mentioned there earlier, is you need to attract money into a business. They're not going there because they like you, because they think they can make money. And the money comes on the exit. No. And the money comes on the exit. Yeah. And I think that shapes also the types of business that you can start up and be successful in if you can exit. And do you think, or I'd just like to get your comments on that, how important is that to identify it early on, when you're the guy with the idea and the inspiration, is to think, I want to sell this business at some point, and then who's going to buy it from me? And like you said, you try and get those guys in already as initial investors.
No, I think that's very important. And also to really understand, that's what I mentioned in the beginning, what kind of business are you busy with? So for instance, Zyra, as I mentioned, there's huge pressure to integrate chips, right? So to think that you're going to be a very big, successful company just on having one piece of the solution, that's you have to realize and understand that that's probably not a great idea. So you have to show that it works and develop it to a certain point, and also not to raise too much money. Because if you raise too much money, then investors are not going to make money, and then they're probably not going to be that nice to you next time around. So it's important to understand, really have a good understanding and feeling for what kind of business you're busy developing, so that you don't overshoot, so that you don't overcapitalize the business as well. But I mean, it's pretty tricky, right? Because if you try and time the exit, it's also difficult, because if the market is in the wrong, if it's not very strong, or there's a recession or something like that, it's certainly a challenge. Yeah. So but it's this miracle, and you've got to believe. So you have to go into it with the understanding that you're going to make it work, and when there's an exit opportunity to really evaluate it and see if it makes sense. Because some of these companies, I would say Truvian and EcoATM were probably the only two that could potentially be like standalone big companies that went public. But even so, I think EcoATM was the right thing to do at that time, because you need to raise so much more money, a ton of capital to take it to the next level. So, just when there's an opportunity coming by, to evaluate that and see, what makes sense and what doesn't make sense. How much money you need to raise, and maybe if the market is really good and it's in a bubble kind of environment, then, because a lot of the companies that's public actually at the moment in the tech space, also the timing was right, so they sort of got propelled into, IPO and being sort of a leader in the space because of timing. And timing it's out of your control, but it plays a very significant and important role. There in the back.
Thank you so much for the talk. It was really great. My question relates to, or if you look at the last three companies, how it's across different disciplines. So it's computer science, engineering, genetics, biology, some pathology. How do we get at the university, get students to start thinking across different disciplines and to interact with each other in different faculties and not just staying in their own faculty? Is it something that we can start doing at a university, or is it something that only happens in practice? Just your ideas on that.
I mean, I never had biology at school, so it's just, if you're interested in learning about it, And so I think maybe give students the opportunity to, to attend different classes, like biology classes, as opposed to just, let's say, engineering classes, sort of across different disciplines. But, nowadays, you can almost learn anything from the internet, right? So everything is there. So if you're really interested in something, you can basically do anything you like. So I don't think it's, maybe the role of the university is to just open people's minds that they can do anything they like, and then they can. Yes?
Peter?
Etienne, yeah.
Is there a swan song?
Is there a swan song?
Yeah.
No, this is it.
Is there, this, we talked about how you start, how do you do this? There's a serial process.
Yeah.
Is there any end in an entrepreneur's head about, where does this go? Or does it just continue?
You mean, is there anything going to be after Pleno? I don't know. I mean, I thought I was going to stop here. So I don't know. It's just, if you find something interesting and you start, let's say, reading about it, and, it depends where you are, and I guess if you're interested in doing something more, there's always something more that can be done. That's at least that we know. So, personally, I don't know if this is the end or not. Yes.
Thanks, Peter. Very inspirational. How disciplined or how formal are you when it comes to testing for product market fit? Confirming or disproving a product market fit, especially in a local context. Your balance sheet is going to allow you only so much time before something needs to start happening in your income statement.
Yeah, I mean, that's a difficult one. I think Steve Jobs said it best. He never did any market research, because a lot of these things, it's difficult for people to normally understand and envision something new, because everybody always knows what they know, and it's more of an effort for people to think about new stuff and how it applies. So I think the best is, if you want to do something, to show people something, so that it's more than just a PowerPoint presentation. So it's difficult, and the thing is, best is to get one company that buys into the vision, as opposed to trying to get like 100 people or 100 different companies, because I think the results are extremely conflicting. So if you get one that's big enough that can be a first customer, just stick with that one for now. That's what I would say. Any more questions? Kali?
Just from a technology view, I mean, there's so many exciting emerging technologies out there. You could nano and strings and
all sorts of stuff. Yeah.
What do you think the next big thing is going to be down the road?
It's got to be AI, right?
And AI and artificial stupidity and all of that. You know.
Yeah, no, I think AI probably in some shape or form. That's probably the most powerful internet-based app, right? So, I mean, I don't know, quantum computing, all those kinds of things. But, you know, 100 years ago, we had basically no phones, cars, planes, anything, you know. Nobody then could envision what we have today. So, I don't know. It's part of, you know, the students and everybody here to come up with whatever the next big thing is.
One, two, three.
Okay, that's it.
Hopefully a quick one, and this is very out of character for me because I'm very interested in all the possible technical solutions, etc. But would you have a framework or advice for young aspiring entrepreneurs to think about, especially at the very start, I think your first company, how you thought about shareholding, controlling shareholding, etc., and whether that is something you would recommend you try and keep control as far as possible between a founder group or get the right investors, and just how to reason about that.
Yeah, yeah, that's a difficult one. I mean, it's obviously best if you can keep the whole company and people just invest in it for free. But I haven't managed that one, no. But I don't know. I think you shouldn't focus too much on the ownership, because because the thing is, you can have 100% of nothing, or let's say 10% of something, right? So it's more important to get going and you know, get capital to do something, because if you do get the opportunity that somebody wants to invest, that's sort of a big deal. So you should seriously consider whatever those terms are. And the best way to get better terms is to have another investor, right? But yeah, don't be too focused on that. That would be sort of my first level advice on that.
Yeah, there was a question over there.
Peter, I need to echo Jacques' comments there. It's really impressive and inspiring. Thank you very much.
Oh, thank you.
On the counter side, I would like to know, what are the biggest mistakes that you've made, or what would you recommend not doing when you're an entrepreneur?
Well, we need another 5 hours for that. No, I mean, I had many mistakes. I think the important thing is when you do something and you realize it's a mistake, just to change course as soon as possible, because the longer you stick to things, the worse it gets. I mean, you'll make mistakes all the time. And that's part of the whole thing, is don't try and figure it all out up front, because you basically have incomplete information. You don't really know. So just jump in and do things and do some course correction along the way.
Okay, then the final question here in the front.
You mentioned work-life balance.
Yeah.
Can you please share with us some of the lessons you've learned in terms of work-life balance, and whether the balance is a myth?
And the what, sorry?
Balance, you know, balance, is it a myth?
Yeah, I would say there's not much of a balance if you really focus on something. And that's why, you know, focus on it, be successful if you can, and take some time off. That's what worked for me the best. Because the thing is, otherwise you don't do as well in, you know, the focus things that you do, and you don't really take off as properly as you should. So if you can compartmentalize that seems to work out, at least for me.
Okay, thank you very much.
Well, thank you.
It's my pleasure to say thank you very much for a very inspiring
life journey of innovation. I think there's a lot of young people here, obviously, that look at you and say, we want to be there, okay? Even if it's only up to number 3 or something like that. But it's really been inspiring. So here's a small little gift of our...
it looks like a big one, but thanks.
It is Milan, so this is our own wine that we make in our cellar next to the First River. So it's yours too.
Thank you very much. Really
Thank you
appreciate
very
it.
much.
Thank you all for listening.
Right, so I feel a little bit like the groom at the wedding now, right? So I've got to thank a lot of people, and I'm very worried I'm going to forget about my mother-in-law or something like that. So firstly, again, Peter, thank you very much. It was really inspirational. I mean, the lessons, and I think, you know, you kind of is a good example of where we want our graduates in our program, our Masters of Engineering Management, want to end up. So thank you very much for being here, and then also sort of being the first lecturer in our Prestige series. Thank you very much for that. As I said, this is the first lecture of the Engineering Management Prestige Seminar Series, and I'm sure, Taryn, we're going to have more of them, and we're looking forward to that. And this program of ours was developed as a new market with innovative and a quality product aimed at early to mid-career engineers and scientists. So we are not eating into the market of the business school. They can still have their MBA students. Nothing there. The innovation and the innovative hybrid and the online delivery model, I think, is working really well. And as you heard, you know, so many students all over the world are attending it. It's true that one was sitting in Antarctica once, right? Yes. So, I mean, one student sitting in Antarctica studying at Stellenbosch University. Of course, the impact of the program far exceeded our expectations in both interest and enrollments, and I'm always very worried about that because each one of them needs a supervisor. So this 300 number, I heard that. But it also shows, you know, that it was a very, very successful endeavor, and it is something for which the time was right, the market was right, the product and everything was just that. And what we really want to do is, you know, we want to practice what we preach. So it's indeed one of our faculty's flagship postgraduate programs, and we will keenly watch on how it develops. So I've already thanked the speaker, and I hope, Peter, that you will actually come back many, many more times to both Stellenbosch, as you said, the most beautiful town in the world, but also to Stellenbosch. The top 100 university to be on the African continent. So I also want to thank and acknowledge both Professor Wim de Villiers and Professor Derej Ramjugana. Thank you for being here, and also thanking for your support. And Wim, I wasn't sure if it was this one or the other one, you know, when I had to do my boetedoening in the Senate, and I had to say my little thing because obviously we did something wrong in the faculty, and you brought me a bottle of water. Thank you very much. I will always remember that bottle of water. So that's the level of support we have from our rector. Thank you very much. I really want to acknowledge also Taryn. I mean, she's the academic coordinator of the MEM program. She joined us as this thing was like going into overdrive, so you had no rest when you came here. There was no time to sort of get into the thing. You had to start running, you know, even before you showed up here. And we really look forward to your continued leadership, and especially the leadership. Big point on that, and your contribution in this regard. So thank you for being here, and thank you for joining us here at Stellenbosch. And she's from Tikkies for all those other Tikkies. I'm also a Tikkie, but we're very happy that you're now a Mate as well. I also need to acknowledge Professor Kali Pistorius, who had the visionary foresight to conceptualize and establish this program at Stellenbosch in close collaboration with very knowledgeable people in industry. And I think, Kali, that is also a key, right? So we actually did go to the market and asked them to do that. Then Dr. Michelle Smith, who's a lecturer in the MEM program, and she was responsible for all the arrangements this afternoon. So Michelle, there she is. Michelle, thank you very much for being here and actually working so hard behind the scenes and making this possible. Then we have quite a number of our industry partners here. So thank you very much for taking the time to come here. I mean, the fact that you are involved in the program is essential to make this program a success. So thank you very much for your involvement, your support going forward. And also want to acknowledge Dr. Lisbeth Botha. Lisbeth baie dankie dat jy het half hierdie ding begin, né? So baie dankie dat jy dit begin het om vir Pieter hiernatoe te bring. Ons waardeer dit regtig en dat jy hier so is. Then all the other staff and students and other guests who are here, thank you very much for attending. And then finally, the staff here at STIAS for their support and their assistance, and all the other people there sitting at the back. Thank you very much for being here. So, of course, I always have to end up with the commercial break. So, ladies and gentlemen, if you would like more information regarding the master's degree in engineering management, or have any comments or suggestions, please speak to Taryn, and also you can speak to Kali, who's still around here. We would be delighted to hear from you. So, thank you for attending, and please drive safely home. Thank you.